Okay, so welcome to the Vancouver Rust Meetup. I'm Jonathan Louie. I work for BitQuill Technologies. They're the sponsors for our events. I'm a software developer, like most people here, I'm sure. And yeah, I've been working with Rust for about 5 years, on and off, and mostly use it for hobby projects. Have dabbled a little bit with it at work for one project that we had at one point, but yeah, now I'm currently a C and C++ programmer. So yeah, that's me. And let's go to our co-organizer, Bo-chan.
Hi everyone, my name is Bertrand Bai. I'm a software developer at a company called Skills. We create game platforms, and yeah, I've been using Rust for about 3 years for now. We recently published a new service to our production environment to using Rust. So yeah, kind of already using that is for my work. What's next?
We can go to Peter Kale.
Mhm.
Hi, I'm a backend developer. What do I love about the Rust community? Mm, predictability, and uh, the memory safety or robustness. Off to you, Jonathan.
Okay. So if we get too many people joining, then we'll cut off at around probably 6:10. Um, let's go with Matthew Sorg. Did you want to give an introduction? Hello, Matthew? Can you hear us? Okay, maybe not. Let's move on to Michael Collins then.
Hey, I'm Michael, software architect at Salesforce. I don't currently use Rust for anything at work except a couple of small tools and throwaway stuff, but I'm quite interested in it for the safety guarantees, essentially. Currently, I'm using a lot of Go and Python and Ruby in work, and I think Rust could fix some challenges with some of those. But right now, it's just for fun projects.
All right, fair enough. Romeo, did you want to give an introduction?
Yes, thank you. My name is Romeo. I'm organizer of the Rust community Stuttgart in Germany. I heard by a colleague that this session will be today, so I started to investigate my time schedule, and it's 3 o'clock in the morning right now, and my position here. I'd like to see what's going on, and hope it will be a great presentation.
Awesome. Thanks for coming out here, even at this late hour. Let's go to Stephen Berrigan.
Hello, everybody. I'm Steven. I'm from LA, so it's like 6 p.m. over here. Not that bad. I'm using Rust to build a new programming language, but I'm new to Rust, so I'm looking forward to learn about lifetime and all that quirks.
Cool. Yeah, I think that will be a very interesting talk then for you. Let's go to Evgeny. Did you want to give an introduction, Evgeny?
Yeah. Uh, Hi, everybody. My name is Evgeny. I live in Richmond, BC. I work in for Press Reader. I'm C# programmer, and I learn Rust as a hobby. don't have currently a job as a Rust developer. That's it. Thank you.
All right. Actually, I might want to cut things off a little bit earlier here because I also need to put up the prize draw form. So let me get that ready here. Okay, so how this is going to work is I'm going to post the prize draw in the chat. So the only field I'm asking for is your name. I didn't want to collect people's email addresses because I know some people are not really comfortable with that. Please make sure that it matches at least your Meetup username or your username here in the Google Meet. So that way I actually know who it is. Otherwise, if you get selected for the draw, I guess that you don't win. Yeah, there's only one entry allowed. If you're, I believe the form requires you to sign in to your Google account. So if you don't have a Google account or don't want to use one, you can always just type a 1 in chat right now and I'll manually enter your name into the draw. But yeah, that should be it. So let me see if this thing is working properly as well. All right, yeah, this looks like it's working just fine. Cool, very good. So I think without further ado, I'm just going to leave that there. We'll come back around to it a bit later. And I'll hand the mic over to Carol and Jake, and they can get started with their introductions and presentation.
Hello, hi, thank you for having us. I'm honored that people are calling in at 3 in the morning and listening to us along with other calls. So I hope we have a great presentation for you. Jake is going to be serving mostly as color commentator and comedic relief. Let me see if I can get my slides up here.
It's basically what I was born to do. I kind of picture myself as the Muppets that would sit up in the balcony and make fun of things. And I get to do that for Carol, so that's fun.
Okay, I have to adjust preferences or something here. I'm sorry, I should have tried this before. Okay. Present, how about a window? Window or screen, select window or screen, okay. Allow, can't share your screen. Okay.
You'll have to restart Chrome if you just gave it the permission.
Well, I'm in Firefox. I thought this would just be real easy. Let me try switching to Chrome.
Or restart Firefox. Carol and I both just got brand new M1 Maxes, so we have new software as well.
Let me try signing out, signing back in. Jake, tell them some jokes.
Ooh. Okay, so now that she's gone, I have no jokes whatsoever prepared. But when she joins back, you all have to laugh and make it sound like it was a really good joke that I just made up. I feel like I should have a joke, like about lifetimes. Ooh, go for it.
If you allow me. My main method of writing programs in Rust is compiler error-driven development.
That's actually not a joke. That's I think what everybody does. Like 100% seriously, yeah. And if there's a joke, it's actually that once the errors are gone, then there's like a 98% chance that your code is also correct. I was lurking in the Discord room and Discord, and somebody was like, yeah, I spent the last 3 days battling compiler errors, and as soon as it actually compiled, all of my tests passed. Like there was no intermediate step. It was just compiler error, code worked. So it sounds like you're doing it the right way.
All right, I think we've got Carol back. Hopefully.
She's got a face.
No.
The slides are
Uh-oh.
really good looking.
So I thought it was a browser preference, but now I'm seeing that it's an OS, Mac OS preference, but I don't know what preference it wants me to change. Share. Screen recording permission. Okay. Yeah, I don't know what it wants from me.
Maybe try Chrome.
I'm in Chrome now.
Okay.
It's saying the same thing. I'm sorry, I should have tested this before.
Maybe someone else can try to share it.
Yeah, Jake, can you try presenting?
Yeah, I'm actually doing that same thing, and I see it just says error, you can't share. Is that what you got?
Yeah.
Yeah. Let's see
Oh.
here.
Okay. System.
So yeah, you're in system preferences, security, privacy, screen recording.
Just finding that, yeah.
Yeah. And then you'll need to click the lock. And then give that to Chrome or Firefox. And then it will tell you that you need to restart Chrome or Firefox.
Okay.
Bochan, did you want to try sharing your screen? I just want to make sure that this is actually working.
Yeah, I'm trying in the same time, trying to find an empty window I can share.
Uh-oh.
No, I think that her leaving is good because when you give that permission from the OS, it makes you restart the whole app to have the permission.
Yes. Quit and reopen. I need to.
There it goes.
Okay, so my screen can share. Oh, sorry.
Okay.
Yep.
You can see mine?
Yep.
We can see our screen.
All right, awesome. I apologize for this delay here. Okay, so our talk today is on borrowing in lifetimes through metaphors. I'm Carol Nichols or Goulding. We're married, and Jake Goulding, as we said, is offering color commentary. We're going to quickly introduce ourselves in case you haven't heard of us. We're going to talk about the purpose and limitations of metaphors in learning. We're going to go through 4 metaphors for borrowing and lifetimes and different aspects of understanding those. And if anyone has any lifetime questions that they brought, we'd love to try and fit them into our metaphors and help figure out and understand borrowing and lifetimes more. So I'm Carol. I'm a co-author of the Rust programming language book. I'm on the Crates.io team. I'm on Twitter at Carol's 10 cents. I am a hockey fan. We have inserted some hockey references in here, and I'm
Carol,
a fan. Yes.
I want to interrupt. I think you're actually sharing like the presenter view of Keynote.
Okay. All right.
Or not the full screen version.
Wonderful, because I was looking at the full screen version, which is, and I wanted to see. Let me see if I can just share everything. Oh, now I'm going to get sharing Inception. Yes. Yes. Perfect. Okay.
Yes.
So how about now?
That looks right.
Okay. So now you're seeing the playing version. Yeah. So my favorite hockey player is Brian Rust of the Pittsburgh Penguins. Jake and I live in Pittsburgh, Pennsylvania.
Um,
Jake, would you like to introduce yourself?
Yeah. So if anyone has heard of me, it would be through Stack Overflow. Online I have various Kirby avatars. That's the one that you'll see on Stack Overflow. I'm the #1 contributor, which means that I spent far too much time on Stack Overflow. I think I have 3 times the number of answers as the second most person. So I really like hanging out there. I'm also a member of the Rust infra team because I'm the maintainer of the Rust playground. So because of that, I kind of got automatically included in the infra team, although everyone else on the team actually does real work. And you can see me on Twitter at Jake Goulding.
And together, we have both co-founded Integer 32, the world's first Rust consultancy. We do training and staff augmentation. And we have written a course that is the giveaway tonight. The lucky winner will be receiving our video course. It's through Manning. It's like a live video series with some exercises and videos explaining things. So we are promoting that as part of tonight's talk. And I believe everyone's already gotten the code. I've also got it on the slides at the end. Everyone gets like 35% off anything at Manning. So we have a code for that. All right. So metaphors are a way I find useful to take something you know and relate something unknown to it to better understand the unknown. Now, all metaphors are going to be limited in some way. There's going to be aspects of the metaphor that don't apply to the new situation. There's going to be aspects of the new situation that don't fit into the metaphor. We are going to call those out as we go through our metaphors. We are going to actually ourselves and explain where the metaphors start to fall down. Please feel free to unmute yourself and ask questions throughout our explanations of the metaphors. We'd love to have some discussion, and we're actually excited about the opportunity to torture our metaphors and try and stretch them in ways that we didn't anticipate to further explain how borrowing and lifetimes work in Rust. So please feel free to unmute and call out any questions at any point during the presentation. All right, so the 4 metaphors we're going to be going through are your mailing addresses through your life, hockey team and rink scheduling, cooking with equipment and ingredients that someone else has provided you, and having multiple projects that you're working on, but only one workshop and workspace to work on them. So the mailing addresses through your life metaphor, the aspect of borrowing and lifetimes we're trying to explain most is what a lifetime is exactly, precisely, technically. And we're also going to use this to illustrate some differences between pointers in C and references in Rust. The idea behind this metaphor is that in real life, you are born and you live at an address, and then you move probably to a different address at some point, and you move to another address, and then at some point you will be at your final address and you will pass away. So that lifetime is what we think of as the person's lifetime. The Rust lifetime is actually the length of time that a particular value is valid at one particular address. So the Rust lifetimes are the times that a particular address for you can actually reach you. When values in Rust move, when they relocate, when you transfer ownership from one owner to another, the value may or may not be actually moving in memory, so that address can no longer be guaranteed to be valid. So the creation of a value to the first transfer of ownership is one Rust lifetime. Transfer of ownership to another transfer of ownership is another lifetime, as many times as you transfer ownership. And then the last transfer to ownership to the time that the value is dropped and cleaned up is another lifetime. Looking at this in code, the way this might look if you have a function where you have a baby at the beginning of the function, the new person doesn't yet exist. There is not a value yet. In the middle of the function, you create a new value, a new person in this case, and you might do other things with that in value in the function. And then at the end of this function, we're returning the new person value out of the function, and that is a move. So the person value is not being cleaned up at this point, not being dropped, but the ownership is transferred. So references to this value are only good in this yellow part of code. At the end of the function, the value is moved and references are no longer valid. If we have a main function where we are calling this, we again have a point at which the value is created and put into the owner named Vivian. Then if we try to take a reference to it, for example, if we want to send the baby a gift at their address, we would take their address, we take a reference to where that value is located. Then let's say that baby moves, the family moves to a different house. The address of the baby is going to change. And if we try to use that reference after that move, the reference is no longer valid, and the Rust compiler rejects this code and says that we can't move it. This is where the metaphor starts to fall down a little bit, because Rust says, no. While anyone else has your address like written down on a piece of paper somewhere and they're thinking about sending you something, you can't move. You can't change to a different house. You can't relocate. So that's a little different in real life. There's no one saying, no, I have that address written down. You can't actually move right now. But to contrast this with C doesn't have this borrow checker. So if you have an address and you send a baby a present at that address, even if the baby has moved, C will happily send the gift to whoever happens to be at that address. It will happily follow your pointer and try and mutate the data at that address, try and access data that might not be what you expected it to be. There's no borrow checker with C. So I mostly just wanted you to use this picture of a cat on a baby toy. So any questions about that metaphor? All right, so our next metaphor is thinking about scheduling hockey teams and games between hockey teams and other events that might happen at a hockey rink or arena. And the purpose behind this metaphor is more conceptual than code. It is to illustrate that the whole reason the borrow checker is worth having as commentary on your code while you're working on it and while you're compiling it is to save you that time at runtime, in contrast with garbage collected languages or reference counted languages. And what I mean by that is that hockey team logistics and arena management is I don't understand how it happens. They plan out an entire season in advance of who's going to play who when, and do things like, okay, the Penguins are going to go from Pittsburgh and they're going to go to play in Vancouver. And while they're out west, they're also going to play in Seattle, and they're going to go to Vegas because that'll be more efficient. So they'll take this big Western swing. And then the arena knows that the team's going to be gone for that amount of time, and they can have events in the arena. And they have this down, they plan everything out and down to a science so much that I was reading about the new Seattle arena. They had a Coldplay concert, and then 12 hours later, they were going to have hockey practice. So they had to tear down the whole concert setup and get the ice ready for practice. And they had to, because it was the first time they were starting a lot earlier, they said that actually they can get it down to like 3 hours, which is which is very impressive to me. But this wouldn't be able to happen without this pre-planning. If the team said, "Oh yeah, we're gonna go play in Seattle," and that while they're out there, like, "Oh, we really should stay out and play Vancouver too," but like, and they call back to the arena, they're like, "Oh, by the way, we're not coming back for practice. Go ahead and have a concert," and then they're like scrambling around, trying to get set for a concert and then trying to use the arena, but what probably would happen is they would just sit around and wait and not be able to have those events because they wouldn't be sure when the team was going to come back and want to have games on the ice. And teams might be flying back and forth across the continent and wasting lots of resources because they would be planning everything on the fly at runtime. So this is like, I thought I had another slide there. This is like in Rust, spending a lot of time, spending all that compile time that you're waiting for the Rust compiler to do all the analysis, so that when your code is running, the Rust compiler has already planned out, okay, this is exactly when we can clean up. This is when we don't need to use this anymore. This is when we're not referencing this over here. And this is what ultimately lets Rust code use way less memory, way fewer resources than comparable programs in Ruby or Go or Python. I love telling the story. I used to work on a Rails app that takes like 250 megabytes RAM just to kind of start up, not even to do anything. That's just the baseline RAM usage. And Crates.io, even under high load, is like 30 megabytes RAM. And that's just like out of the box for both those. Rust is still doesn't have quite Rails, but a web app that is handling lots of traffic is able to do that with way fewer resources than a comparable Rails app. Any questions about the hockey arena management metaphor? All right. So another aspect I feel like gets lost about lifetimes is that the annotations in code are all about relating inputs to a function to the outputs of a function. And that's their main purpose. So the metaphor I have to understand this is imagining that you are a chef cooking in a restaurant and someone else is managing the kitchen equipment, someone else is managing the ordering of ingredients and supplies, and you show up to work and you are cooking. Your inputs are the ingredients like the meat and the cheese and the vegetables, and you're also going to use knives and spoons and cutting boards and other equipment, and your output of your function is going to be burgers today. And the question that lifetime annotations is going to answer is, how long are the burgers going to be good for once I've cooked them? And you can answer that in terms of how long the ingredients are going to be good for. And the ingredients are those inputs that go into the final product. It doesn't matter if the knife wears out, then that's not going to affect how long the burger is going to last in your fridge. You can say the burger meat and the bun and the tomatoes and the cheese and that whole product is going to last as long as the ingredient that is going to spoil first. So that's where the lifetime of the output is the smallest of the inputs that are annotated, have the same annotation with them. Let's look at some code. So here's a function where you're making burgers and you've got your ingredients as inputs and your equipment as inputs and your outputs is a burger. And in the function, you're creating the burger, and you're going to be creating the burger using those inputs that are ingredients and not the inputs that are equipment. So to express this in your function signature, you would declare a lifetime and give that lifetime to the references of the inputs that are going to be part of the outputs. So this burger is going to hold references of the ingredients. It's not going to hold on to references of the knife or the cutting board. This is kind of glossing over mutability, and I'm deliberately leaving off of a definition of the burger struct and what you might do with that. But I wanted to use this to show how inputs and outputs relate in like you would in a kitchen making food. Any questions about that metaphor? Okay, our last metaphor is having multiple projects in one workshop. And the purpose of this metaphor is to talk about how having references and managing references lifetimes gets tricky when you're doing threaded code or asynchronous code. So imagine you have a workshop where you have a whole bunch of projects in progress, but you've only got one workspace, one working table. So you get out a project and you work on it a little bit, and then you need to switch to a different project. So you need to put away your current project, put that on a shelf somewhere to make room for another project that you might work on for a while. And if you have a project where you've borrowed a tool from a neighbor and you don't own that tool, but you're using it for one of your projects, and you try and pack it up and put it away and work on a different project, by the time you come back to that project, your neighbor might have come back over and taken their tool back, and you might go to get that project out and not be able to work on it because they've taken their tool back, because you tried to store something that you don't own. So that's kind of similar to how lifetimes and borrowing get complicated when you're using threads. So I've tried to translate this metaphor to code here. We have a hammer, we have the neighbor's hammer in the main function. The neighbor's hammer variable is the owner of the hammer. We try and start a thread that we're going to work on at some other points, and we're going to work on a shelf and borrow our neighbor's hammer. And at the same time, the neighbor might come back and reclaim their hammer and take ownership of their hammer again. And if you try and compile this code, it won't let you, because the thread might complete first, or the main might complete first, and Rust can't guarantee that the hammer is still going to be where at the address that the closure on the other thread thinks it's going to be. We have a slightly more tortured version of this metaphor we were working on, where you have like a kind of a board or something. You're taking apart something and putting the pieces in specific places, and you're trying to put away this entire board, and so that you can get it back out and you can know, okay, I needed the thread, the screw that was third from the top, but as you're pulling it back out, it kind of jiggles a little bit and everything moves, and it's not exactly where you thought it was going to be. So this is how you might think that Rust should be able to set aside your data and keep the references in relation to the data, so that the references are still available when you pull those back out to do further work on that thread. But Rust can't guarantee those references are going to be there. So this is why it's way less complicated to transfer ownership to threads, to asynchronous functions, so that when you put those things aside and work on something else, the thread and the asynchronous futures can manage where all of those things are and know where that data is going to be when it starts back up again. Okay, I'm gonna step back out of this so I can see everybody again. And yes, Inception, wonderful. How do I stop this? Okay. All right. Does anyone have any questions about our metaphors or any other lifetime questions that we could talk about? So this is kind of an experiment. I'm not sure how well these metaphors match up with what actually happens. I don't know if these are going to be helpful while you're coding. So even if you don't have any questions right now, if you think about these later and run into problems, we'd love to hear if these metaphors helped or if they caused more misconceptions or any of that. We'd love feedback on this at a later time, because I'm always looking for ways to make lifetimes and borrowing make more sense, because they're just so different from other programming languages that I want to have better ways to teach them. And I hope I've provided some. So any thoughts anyone has would be very welcome.
Hello, can you hear me?
Yes, hi.
Hi. Yeah, so first, thanks a lot for the presentation. Really enjoyed it. I am fairly new to Rust, and I was actually wondering for the burger metaphor. I'm coming from a C++ background, and it made so everything you said made perfect sense to me. And here I was wondering, because the burger toppings and cheese and actually passed as inputs to the function get actually transformed. Why wouldn't pass those by moving them inside rather than borrowing them? Because once we borrow some toppings, we might not have any more after, or same for the cheese, or might not be in a state where we can use them as we would initially.
Yes, that's a very good point, and was kind of a failing of that metaphor. I mostly went with burger because I found that nice picture that really illustrated what I was going for really well. I think a better metaphor would be more of like a salad or a fruit salad or something where you're not so much changing the ingredients, you're just kind of assembling them together, which is more like what you would do with immutable references. Is you might group them together in a certain way. You might take a slice of them and then pass that along further to the consumer of the function. With mutable references, that would also be more like the burger case. And with mutable references, you can only have one at a time when you're calling this function. And that I didn't really get into that at a time part of lifetimes with mutability. I'll have to work on a metaphor that works with that. Jake, I'm not sure if you had anything to add. I saw you shaking your head.
Yeah, I was thinking, I do think that it makes sense that in applying the metaphor more literally, yeah, you probably would take your toppings and the patty and all that, and that would probably be moved in. You would take ownership of those, and then the actual burger would then own those. So I think, yes, we might have to find a slightly different concrete object to draw that metaphor to. I think that's valid.
And you and I also talked about how sometimes cooking or baking something changes how long it lasts. For example, we're working on a fruit cake that is, you preserve it over 2 months. You feed it alcohol, and it preserves it. So that is actually extending the life of some of the ingredients that we put into it, which in Rust, you can't make anything live longer than it's going to live.
Yeah, if you ever hear somebody say the words extend the lifetime in Rust,
or how do I make this live long enough is often
a major red flag. You're like, that's the wrong way to look at it.
Yeah, because you can't really, unless you switch your data structure entirely to something like an arc, like there's no making something live longer. Yeah. So that's definitely,
makes sense.
Yeah.
Thanks.
So yeah,
You're welcome.
Think of something that's not like, I'll give you a reference to something in the burger and then I'm going to take it back later. That's a little gross. So we might have to come up with a different concrete thing.
Yeah. Yeah. Okay. This is another metaphor that I left out because I think it's a little tortured more. So like actual libraries, right? And you check out a book and you have a due date for the book. Say you create some art using the book, but you can't change the book because you have an immutable borrow of the book. So you can just kind of like decorate it or something, put a frame around it, and your artwork is only going to be valid as long as your loan from the library is going to. So you can only have it up on the wall at a gallery until you have to return the book to the library. And again, this is really tortured because it's like no one's ever going to do that. This isn't a real life scenario, but I feel like it maps a little bit closer to what happens in code. Is that if you have a reference to something, you can use that reference and pass it along as the output of your function, but it's still you're not extending the lifetime of it. It still has to end when the lifetime of your inputs ends. I don't know. Ooh, rented car. I like that. I have to think about that one.
I'm not sure what it is, but I often go to cars for like general, like immutable versus mutable versus ownership analogies. Like nothing concrete here, but like, I'll let you borrow my car, or I'll let you borrow my car and paint it, but that doesn't actually give you the ability to sell my car, for example. Like I still maintain ownership. I feel like there's something about cars where ownership and borrowing is something that is kind of day-to-day familiarity.
See, I've been scarred by car inherits from vehicle object-oriented things that never really made any sense. So I try and stay away from car metaphors.
I have a question on the last, like the toolbox, and this is probably just a little bit more of a REST question about multi-threading. But what if you have just an object that you don't mind them sharing the same shared data on each thread? So like a counter, for instance, it's only going to go up. You're just going to keep on putting the counter up, and you don't want to have to pass a different counter and then add them up later. Is there a way to do that, or does that fit in with this at all? Or
yeah, I think that could fit in. I'm trying to think of like maybe something like you're working on a project with someone and you're each building pieces, and then you put the pieces in like a finished bin, and you can both put stuff in the bin at any time. You can both be throwing stuff in there, and that's okay. I was trying to do something more like locking, but I didn't want to get into like mutex stuff too much, where you have to like say, okay, this is my turn to change the value. No one else can change it. I was trying to think of a scenario that isn't like Git or like a shared. I'm trying to stay away from software, and all I could think of was software. But yeah, I think having something that's explicitly shared, everyone who comes into the workshop knows they could use it or work with it or add to it or take away from it, and that no one's taking ownership of it and preventing other people from using it. Yeah, I think there's something there.
Make a nail bin or something where there's
Yeah,
essentially endless
yeah.
nails, and you don't have to worry about it. You just kind of, or like maybe it's the nail trash bin where every time you move a nail, you can just throw a nail in there. No one cares. No one's gonna, maybe overflow or something. But
yeah. It's definitely, Jake and I had fun just talking about these metaphors and trying to extend them and then being like, oh no, that's not right at all. Yeah.
You mentioned mutex, and like this would not be great for this talk because it's like the opposite of like you mentioned trying to stay away from software, but this is actually even closer because like some people actually think of the mutable and immutable borrows as kind of a compile time analog to a mutex. A mutex, you can, or not a mutex, a reader writer lock, I should say, where a reader writer lock allows you to have multiple immutable borrows or a single mutable borrow. So some people who come from a highly parallel concurrent background actually find that useful. It's like, oh, Rust can do that at compile time. It has a compile time reader writer lock. So it is an analogy, but it's even further away from real world analogy and like analogy to existing technology things. So maybe useful to someone, but maybe not for this talk.
Yeah, I know a lot of people have found understanding by thinking of ampersand mute as an exclusive borrow and ampersand as a shared borrow. That didn't really resonate with me, but I think like C++ shared pointer, exclusive pointers, smart pointers, that fits in with their mental model. Rajat, you raise a hand?
Hello.
Hi.
It was an excellent presentation. So I have a question. How often do you rely on arc or mutex, right? Arc mutex combination, rather than like restructuring your data structure or rethinking about the format? How often do you do that? Because I've been trying to get away like thinking of different ways to not relying on arc and mutex, just to understand how I can solve the riddle, right? But till now, I haven't been succeeded. Okay. In the multi-threaded scenario, I mean, of course.
Yeah, and as with all good questions, the answer is it depends. Jake and I are working on a project right now that is doing a lot of asynchronous code. It's multi-threaded. It's trying to be useful from having many threads and many workers working on things. And there's arcs and mutexes everywhere, just like absolutely everywhere. The other way I like thinking about it is not just like sharing and syncing across threads, but it's when you're not sure who is going to be the last owner of a value. So, and this is it really clicked with me when I was working with like web servers and requests. You don't ever know which request is going to come in first and which request is going to come in last, and when you can actually clean stuff up. And like you might even shut down the server before a request is finished processing, if that works that way. So if you're in a situation where you're not sure which function or which owner is going to be the last owner of some data, then an ARC is exactly what you need. If there's a way where it's like, okay, no, this is going to start and it needs to create value, and then it's always going to be valid until this particular data structure gets cleaned up, then that might be a good case for references. But again, once you're sharing across threads and asynchronous, it's just so much less pain to just put it in an ARC and ARC clone. I also really like the idiom of, instead of saying .clone on when you have an ARC, doing ARC : parentheses, ARC : clone parentheses ampersand ARC value, that what Jake typed in chat. I hate trying to say code out loud. Thank you, Jake. So that you can quickly read through your code and search through your code to see which clones are the expensive clones and which clones are the cheap clones, because clones of ARCs are cheap. So you should feel good about doing those everywhere. Whereas a regular clone could potentially be more expensive and copying more data around on the heap. Does that answer your question?
Yeah, it does.
Okay.
Thank you.
Did anyone have?
I mean, this ARC clone thing, actually, I read it in the book, but forgot actually. So
Yeah,
it made sense.
yeah.
Totally. Yeah. Just
It's.
keeping a reminder.
I feel like it's one of those idioms that isn't universally liked, and some people don't care to use it. But I once I understood why, it made a lot of sense to me to use it. Did anyone else have any situations in which you use ARCs or not use ARCs, or anything to add?
I was going to chime in. So one thing that Ninja 32 does is we do training. So I've been doing a lot of training this year, and similar questions have come up around ARC and things like that. And one thing that we try to really hammer home is that when people are writing Rust, we often end up being over performance worried. Like we worry about it too much. And I think that Rust is a great language for that. And I am 100% in this camp of somebody who worries about performance too much. And like Carol said, like cloning an ARC is literally incrementing a single integer. Like that's what an ARC clone is. So not very expensive. And, is it more expensive than not doing that increment? Yes, but you're incrementing a single number. It's not that much. So we try to be very pragmatic about, there's times when doing ownership instead of borrowing and lifetimes, as Carol says, like so much easier. And so we should never actually feel bad about that. If anything, use the ownership technique, put it in there. If you feel really bad about it, put a little comment that says to do, can I avoid this? Maybe come back to it. So in overall, I wouldn't say to worry about it. It's fun to try to remove them. And there are some techniques. So this doesn't work for async code, but for multi-threaded code. One thing that you can sometimes do to avoid an ARC, at least, maybe not always a mutex, would be to use like scoped threads. So something like Crossbeam allows you to avoid creating ARCs sometimes, not always. One other thing that I like to point out is that these two techniques both work in different cases. So if you could always use lifetimes in borrowing instead of ownership, we wouldn't need ownership. If there was something that was always uniformly better than an arc, we wouldn't have arc at all because there would be no reason for it. So there is always going to be a time where using an arc mutex, something like that, is going to be the best solution. So definitely don't think that if you type the words arc in your code that you've done it wrong. Absolutely not.
Okay, let's go with Romeo.
Jake, you just wrote some lines there. I didn't get the difference. Can you explain it in one sentence, please?
Not in one sentence, but I'll try my best. The short thing is, to the compiler, there is no difference between those two lines of code. That's important thing one. The important thing two is, to the programmer, we can now see in the source code that we're cloning an arc, which we know just by, having read the docs for arc. We know that arc clone is cheap. Whereas if we just see an arbitrary .clone, we don't know exactly which thing's being cloned always. Maybe that was a vec of, 10 billion elements, and all of a sudden cloning that's going to take up a whole bunch of memory and time. Whereas if you see arc clone, then you know that it's going to be very cheap. And as the comment there, it makes me nervous by default. This is kind of also tying into that Rust attracts these very performance-minded programmers. Cloning memory is bad. And I want to pick some middle ground here where it's not great if you can avoid a clone, but you can't always avoid a clone. And if you're cloning an arc, then you know that clone is not going to be a bad thing. And like there's a comment there that kind of talking about if you change the type, then maybe the clone becomes expensive. And the flip side of that is sometimes you actually have a type that wraps around an arc. So you have to extend your mental vocabulary of what types are cheap to copy or cheap to clone. So sometimes you might see other cases where it's like my custom type : clone. And you just have to be like, well, I know that my custom type is cheap to clone because it's built on top of an arc. But so definitely not one sentence answer, but hopefully that got it for you.
Okay, I understand. But in general, it's just more verbose. So you know that it's an arc when you clone it, and on the other side, you clone something that might be an arc. So if you have an arc, just use arc clone. Okay, thank you.
And there is actually a Clippy lint for that, which I'll paste the link in a second. But
And let's go with Amit.
Yeah, just want to share another example where Arc is useful, which I have used in Actix Web, where when you are cloning a database, you are having one database connection and you want to reuse the same, and you want to share in multiple threads. So just wrap it with Arc, and then we clone an Arc and pass it multiple calls, right? So that is another instance which I'm using.
Yep, exactly. And I don't know of a way to do that with references. So, yep.
Okay. Do we have any other questions or comments?
I have prepared a session for newbies about ownership and lifetimes, and I just want to discuss some ideas that I have about it. Is this possible? So I would have access to the screen share if it's
Yeah,
possible.
go ahead. Yeah, we have time.
I'm blocked right now, so I don't know who's blocking me.
Oh, I don't think there's anyone blocking you right now, as far as I know. Maybe it's your security settings, or
you must grant permissions in order to screen share.
Are you on a Mac?
Yeah. Are you on Mac OS?
No, Windows, Firefox.
Yeah, I don't have a solution for that. I'm not on a Windows machine.
Okay, I try to figure it out. Thank you.
Yeah, we can come back to this. Does anyone else have any other questions or comments before we move on to our usual news segment?
In the chat, I just pasted the discount code that will get you 35% off anything at manning.com and our Twitter handles if you want to tweet at us later.
All right, thank you.
And thank you for having us.
Awesome. All right. So I'll get to the prize draw again here soon. Let me just post the link one more time for people so that they have a chance to enter their names in. And well, I guess Romeo. Oh, I guess he's ready now. All right.
Yes, I love it already.
Yes, the idea is to show the stack and to have some program code on the other side of the screen and to explain it with code and some sketches with it. So can you see what I'm drawing?
Yep.
So this is the stack, and I will allocate that X, and this is the X place in the stack. So in the end, when you make let Y is a reference to X, you have here a Y pointer that references to the X. So in the end, the question is that only these arrows here point into this direction. It never can happen that something can happen like this. Is this true?
So I haven't really thought about it like that. My first thought is that this might not be very helpful once you get into the heap, which is where borrowing gets more complicated. And I'm not sure. I'm not sure what this knowledge gets you. If you know the arrows can only go one way, what can you build on top of that with that knowledge? And maybe you're going to get there.
It's like a technical metaphor for myself, but I think it is helpful to understand it because you have here str, and this is a pointer to somewhere on the heap. And if you have here, for instance, an A and here a B, it would be a B reference, and this would also reference to this section in the on the stack. And if you dereference it, and it automatically dereferences it, you will have two jumps to hello.
Okay, and I guess like if you move ownership, if you say, okay, now we have C and that equals X, then that invalidates Y because then the arrow couldn't go forward.
Yes, X is an integer, so it is a copy trait. This would be just copied.
Yeah.
But if it's not a copy trait, it is moved. So everything on the stack gets moved all the time. But if you have a copy trait on it, then it keeps the value and it is not invalidated. Maybe I'm too cumbersome in my explanations, so I think you cannot understand what I'm talking about.
I'm letting it sink in. I don't know if anyone else has any thoughts. Feel free to jump in.
One thing I was thinking, so you're talking about the stack, but you're also showing some code here, and I'm throwing some code into the chat. But basically, one thing that people don't necessarily always know you can do, but is possible, is that you can declare a variable without immediately assigning it. So it is actually possible to, I don't want to use these words, but like forward reference something. Now, the way you've drawn the picture, you've got the stack, and I don't actually know 100% which way the variables in my little sample code get allocated on the stack. They might get allocated actually as B first on the stack and then A. Rust may reorder them. But I don't know if that throws a wrench into the concept of things only going in one direction.
Okay. So this is just a mental model that I developed. I did not dig into the compiler code. Yes, the compiler code. And I don't know how the borrow checker works. I just try to figure it out just by trial and error. And this is my mental model that I'm doing here.
Yeah, and I think it's really important to have lots of mental models when you're teaching, especially because some mental models will click with some people and some will click with other people. So if this clicks with you, there's a good chance it will click with someone else too. So yeah.
Okay. I didn't get some feedback from my participants at this workshop, but maybe it's too complicated for some people to get around this mental model. Is this too complicated? What do you think?
I can definitely see that if the people in the workshop are coming from something like Ruby, where you're hardly ever thinking about the stack and the heap, where if their participants are coming from C and C++ and kind of lower level systems languages, this might be a better choice for them. But even just this is making a lot of assumptions that people are already really comfortable with the stack and the heap, and that might not necessarily be the case. I don't know about your workshop participants.
Okay. So my general focus group is people that have an understanding of C and C++, and therefore are familiar with stack allocation, heap allocation. So in general, people who studied computer science at all. Yes, I think I just need to think about it if I can, how do you say, water it up a little bit or blur it with other metaphors. Okay, thank you.
Thank you for sharing.
Cal and I are both really big fans of visualizations. One thing that we debated for a reasonably long amount of time and ultimately didn't do for our Manning series was actually having taking code, printing it out on physical paper, and then putting hole punches next to each line, and then getting colored thread and weaving it through the page to show the literal lifetimes, and then having it go into and out of functions and like have multiple pages, one page for each function, and being like, look here, and then these get tangled up together like this.
It was a
and
big mess. It was
Yeah.
a tangle. We tried to do it with like one function, and there was just like string everywhere.
But I do think like the actual doing that, like physically running that thread through yourself, is a fun and useful activity. So maybe we need to revisit that as like a hands-on thing for a conference workshop or something like that.
I realized that this gets very complicated to explain such stuff, and I know the problems you have.
One thing that you have really going for you with your target group there is that as long as they've had some amount of experience with C or C++ or maybe even Pascal, they've experienced the pain that Rust was effectively created to prevent. So if you just have them remember the days, weeks that they've spent in GDB debugging something, that's effective. Like all that time where they've had to hard learn something, that's where the Rust compiler just gives you an error message instead. And, you know, it's frustrating to get that error message from the compiler, but they've already gotten that error message from, you know, their production code not working. So C and C++ developers tend to be fairly receptive to it.
Yes, thank you.
Even Go. I've had issues in Go that would have been caught with borrow checker and lifetimes.
That's always like a weird thing, right? Because you're like, oh, this is a high level language. I don't have to worry about these things. And Go is an interesting position where it kind of tries to walk the line, and sometimes it's on this side of the line and sometimes it's on the other. I think Swift is also kind of similar, like trying to walk that line between high level, low level. And, you know, I think Rust definitely shows it's not an easy line to walk, you know? So I'm glad that there are more and more languages trying to walk the line. It makes me very happy.
Peter, did you want to explain what that wouldn't fully describe? I'm a little bit lost on the context.
Oh, that the drawing doesn't apply here. This is similar to what Jake mentioned, like forward booking the variables, and I guess the different the stack and the fact that the new variables can refer to the outer ones, if you like, or older ones, does apply, but I believe that also because of non-lexical scopes, it's I'm not sure if it's exactly related to non-lexical scopes, but no, to me it seems that the lifetimes are like in groups rather than every new variable, as in the order of the code, has its own lifetime. But there may be someone who knows how to explain it better. But here that R reference can, yeah, it was defined before Y, and it can still point to Y. But I believe that's because they probably share the same lifetime. I don't know if there's any formal difference, but in practical life, to me it seems to be the same lifetime.
All right.
I think what Jake mentioned on the presentation from Romeo, right? since compiler decides how to like make the stack, right? So the whole point is that I think even in C++ also, if it makes to compiler to rearrange the things to variables or assigning the pointers in certain way so that reshuffling is not done later, I think it would go that way. So I'm not sure how much that stack thing would help in making a mental model for like next person actually.
And one thing to note is that, you know, if you are trying to build a mental model, you know, the only perfectly correct mental model is what the code in the borrow checker itself does, right? So I think it's reasonable to have mental models that are partial. Ideally, the mental models aren't wrong in some case, but you know, if you can clearly delineate here is at the extent of this mental model, you know, it goes this far and then you shift, you have to do something more complicated. If you can identify those points, it's kind of like what we're doing with the metaphors, right? It's saying here's a metaphor, which I guess in saying this aloud, a metaphor is a mental model. You know, you say it works this far and that's as far as it goes. You really shouldn't go past that because then it starts being nonsense. So, you know, if what you've got there makes sense and can get people started or, you know, to some distance and doesn't actively put them on the wrong path, you know, it's not ultimately misleading, then I think even partial mental models are useful.
Okay. Do we have any other last minute questions or comments, feedback? Going once, going twice. All right. So we don't actually have time to do the usual news segment. That's okay. I want to just quickly get the prize draw out of the way here. So let me just share my screen. Hopefully it works. All right, everyone can see that, right? Okay, excellent. So here are the names that we have listed in the Google form. So what I could have done is do a rand between to pick a winner, but I decided to, you know, make things a little bit more fun. We're going to do it with Rust. We're going to use the rand crate. So if you don't win, you know what crate to blame. And basically, this is a cute little program that just generates a random number between the start index and end index inclusive. Just note the equal sign. And we're just going to give it the row numbers here and see what it comes up with. So spin the wheel. All right, we got an 8. And that is Peter. So congratulations, Peter. You have won the prize draw.
Oh, thank you, Jonathan. May I ask Carol or Jake, it's 4 hours video and 62 exercises. Is it? I'm not claiming to be a Rust expert, but I've been learning it for about a year, a little bit. So could someone else benefit from it more, you think?
I don't know. It depends. Take a look at the topics and see if the topics we cover look interesting to you.
I'm trying to remember exactly what our phrasing was. It was like
We're
the things that are unique to Rust,
Yeah.
right? Yeah.
We're trying to get at the things that are most different about Rust and not, it's definitely not like a comprehensive, it's not as nearly as comprehensive as the book, and the book isn't even comprehensive. So it's trying to get you kind of started getting into Rust concepts so that you can use something more referencey. So if you are feeling good about concepts and like error handling and borrowing and lifetimes, it might not be that useful for you, but I hope that everyone would learn something new from our course.
Oh, okay. I would learn you, but to help others. Jonathan, would you like to do a second draw, please? And thank you.
Oh, sorry. A second draw?
Yes, please. I'll pass. Thanks.
You'll pass? Okay. Sure, we can. Well, let's spin the wheel again then. Let me just share my screen again.
Jake, the playground was pretty slow that time.
The playground has been slow for like a year now. It's really terrible. It's funny. So like a little behind the scenes here, the playground runs on like a single EC2 instance, has like 2 cores, and like everyone across the world, like when you like are running things in the book or like the API documentation, it's it all uses the same server. There's actually a play.integer32.com, which basically only I know about, and so it's really fast. But
okay,
it's actually on a smaller EC2 instance.
Maybe I should use that next time. Anyway, let's spin the wheel again. So 3 to 9.
Also, it's way more dramatic the longer it takes.
That's true, yeah. We got a 5. 5 is Bochan. Okay. Congratulations, Bochan. You won. Oh wait, is he still here? Oh, he's there. There he is.
Yeah, I'm still here, but I'm thinking I should give it to someone else.
It's fine. If no one wants our course, that's fine.
Okay.
Should I spin it again?
Yeah, just do it again. It's for the last time.
One more time?
Yeah,
okay,
for the last.
This is the last time. Okay, no backsies, guys, please.
Yeah, whoever got this, if you don't need it, just give someone for your friends. Don't draw it again.
I should have said if you weren't interested in the prize, maybe don't don't enter your name into the draw. All right, 3 to 8. Let's try this again. Drum roll. Ooh, this one's taking a bit longer. Okay, we got 6. 6 is Justin Barclay. Okay, is Justin Barclay still here?
Yeah, I'm still here.
All right, well, congratulations. You've won. Please don't ask me to spin the wheel again.
You must take it. You must have it now.
Please.
I will happily take it. Thank you.
All right, thank you very much. And thank you, Jake and Carol, for coming out to our little meetup and telling us all about lifetimes and all the metaphors about them. It was really helpful.
Thank you for having us.
Yes, thanks a lot.
Thank you.
Thank you so much.
Thanks, guys. I'm gonna buy the combo book and course. So.
Yay! Don't forget
next week. I took next week off to have a quiet week, so I'm gonna enjoy doing it.
No, don't forget. There's a discount code for that.
Oh, I saved it already.
Okay, good. Very nice. Cool. So yeah, that's it for today's meetup. Thank you all for coming. It really means a lot to me that you all came out here, especially those of you who came from different time zones and where it's like super late. So yeah, unless you have any last minute feedback or questions. Oh, actually, I just want to do another quick plug here. We are looking for participation in the Rust meetup. So if you have any topics that you're interested in talking about, we'd gladly have you come speak. You can always ping me or Bochan and let us know, and we can help schedule you in to do a talk. But yeah, that's it. Thank you all for coming.
Oh, I was just wondering, is there any stipulation for that? Like what kind of topics and
I think we have some details up on our meetup page. I can't remember where. I've definitely posted it somewhere. There are some guidelines there, but just to recap, generally 30 minutes to an hour. That seems to kind of be the sweet spot. We've had talks that went way over an hour before, and people kind of lost interest.
Yeah.
It has to be about Rust. It has to be related to Rust in some way. But otherwise, it can be whatever you want. It could be a workshop even, if that's something that you're more interested in. But yeah, you can just let me know or let Bochun know. We'll help get you scheduled, and yeah, we'll handle all the behind the scenes dirty stuff.
Awesome. Thanks. Yeah.
All right. So with that, that's it. Take care, everyone.
Thank you, everyone. See you next month.
Bye.
Bye. Thank you.
Thank you. Bye.